Hi, the example 3 for time diagram. So suppose that the annual effective rate, interest rate I is equal to 10%, and the quarterly deposits of $100 each will be made for 3 years. So that means we have in total the 12 payments, 12 deposits. And the first deposit will be the 3 months from now, and how much is the accumulated value. So the point is that the time unit is not a year, but the time unit is a quarter. So time unit is a quarter, 1 quarter a year, or 3 months. So in some questions, we don't really have to use the the 3 months as our time unit. But in this case, obviously everything is the quarterly, so it's convenient to make the time unit equal to 1 quarter a year. So the one thing we have to be careful is interest rate also have to be converted to the quarterly rate. So quarterly effective interest rate. So this is a key. So if we want to convert everything to a quarter, then interest rate should be also for a quarter. So the effective rate, okay, so I would say this as J. Then what is J? So annual effective rate is 10%. So that means that for quarter, $1 becomes 1.1 to the 4th power. And this is actually includes the principal, the original one. So $1 becomes this amount. So we subtract 1 from this. Then this is the quarterly rate. So this becomes actually the 0. You can guess this is just a quarter of 10%, so around 2.5%. But you can see slightly less than 2.5% because this is quarterly rate. So basically it compounds 4 times in a year. So a little less than 2.5% can make 10% effective rate for a year. So J is equal to 2.411%. Okay, so we think about the V. Actually, the V corresponds to J here. So 1 over 1 plus J. Maybe we should use another symbol, but anyway, so we are using only the quarterly rate. So we define V as 1 over 1 plus J, and this becomes 0.97645. Yeah, and now that we want to calculate the accumulated value. Okay, so we use the time diagram. So we have 3 years. That means the 12 quarters. So quarter, okay, so quarter year, 0, 1, 2, 3, up to 12. And we have the deposit of $100 each. So 100 at time 1, 100 at time 2, 100 at time 3, and up to 100 at time 12. And we want to calculate the accumulated value. So accumulated value is here. So we have to calculate this. There are several ways, but yeah, we can directly calculate this. But yeah, so maybe for now that we want to calculate the present value first. Then after that, we can say the accumulated value is actually the present value is the accumulated value. Sorry. present value is accumulated value times the v to the power 12. So once you get PV, we can get AV, accumulated value. So we calculate the present value. Okay, so we calculate present value first. And present value is, okay, so actually the 100 times V plus 100 times V square, 100 times the V cube, up to 100 times the V to the 12th power. Because think about the first payment at time 1. So this is worth 100 V at time 0. And the second payment, second deposit. So this is worth 100 times V square. So we can do that for all 12 cash flows. So PV is equal to this. And you can use a formula to calculate the sum of geometric sequence. So this is 100V. 100V is the common factor. Then the remaining term is 1 plus V square plus up to V to the 11th power. So that means this is equal to 100V times 1 minus the V12 over 1 minus V. So V is less than 1. So we have the discount, so less than 1. So it's convenient to say 1 minus V12 over 1 minus V, so that both numerator and denominator are positive. Then without adding the 12 different numbers, you can get this as $1,031.30. So $1,031.30. So in this way, we can use the time diagram, and we use the quarterly rate. So we can change the time unit, and we can describe the time diagram to solve the present value. And accumulated value is actually the V negative 12 times PV. So that is 0.97645 negative 12 times 1031.30. So it's smaller than 1031. So we go back the 3 years. So basically annual interest 10%, about 30% less. So about $700. Oh, sorry, the AV is three years larger. So we have to multiply basically the 3 years of interest. So 30% larger. So about $1,300. And actually this becomes 1372.64. So $1,372. Yeah. So this is example 3. And so now that we have, we want to solve this question by using a calculator. So this is very common, the cash flow. So we have the same amount every month. For example, the mortgage payment, we have the same amount. We have to pay the same amount each month. Then we want to calculate the present value. Present value is basically the present value of the loan. So you borrow PV, then you pay back the $100 each month, each quarter. So this is very typical, the cash flow. So the function, the BA2 plus, the calculator BA2 plus has function to calculate this. So yeah, so at first to calculate this, that we use the time value of money function. So basically this is non-trivial question because 100 isn't worth 100 at time 0. So basically it's called the time value of money. So $100 is worth less than $100 if the time goes back. So time value of money function. So to choose that we at first in BA2 plus push the second button. Second button is maybe the second one from the top and the most left. Okay, so second. Then TVM function. So TVM. So clear TVM. So at first we wanna clear any memory that remains in your calculator. So you can type CLL-TVM. So CLL-TVM is the right key and the third one from the top. Actually, this is FV button, but if you push second, then this becomes clear the TVM function. Then we have to input the all information. So at first we have the 12 payments. So we can enter 12, 1, 2. Then we enter N. So N is the third line and the most left one. So then the calculator recognized we have the 12 payments. So N basically also works as an enter key. So 12, we enter N is equal to 12. Then we have to enter the interest rate. And the interest rate, we are thinking about the quarterly interest rate. So we have to put the 2.411%. So, and also we have to input this as percentage. So 2.411 I over Y. I over Y is next to N. So the second one from the left and the third line in the calculator. So 2.441. Maybe this is approximate, but okay. So for now, 2.411. Okay. Then next, the payment of $100. So 100. But actually the BA plus recognize the all amounts as the cash inflow. Okay, so all amounts as cash inflow or all amounts as cash outflow, we can say. So we have to get the positive present value, so that we have to input the payment as negative ones. So the 100. So if we put the 100, this 100 on the other side, then we should put negative 100. So we have to put negative 100. So we can type the plus minus key at the bottom from the second one from the right. So so 100 negative, then payment. Payment is also in the third line and the second one from the right. And payment. Then now we entered all necessary information. Then we type the compute. Compute is actually the most upper left key. Then we want to calculate present value, so type PV. Also the future value, that is AV button. But okay, so this time we want to calculate present value. So compute present value. Yep. So 100 negative payment and compute present value. Then you should get the 1031.3. So this amount. So 12N. So at first the clear TVM and the 12N. Clear TVM 12N and the 2.411I and the negative 100 payment, then compute present value, then 1031.326095 you will get. Maybe you have to change the format. Maybe you will have only maybe 2 digits after the decimal point or something. You can change that setting. You can see the instruction of the calculator. So you have to get used to how to reset and how to set up the calculator as you want, because during the actuarial exam, the supervisor of the exam, they reset your calculator. So even if you optimized your calculator, it will be reset. So that you have to know how to make it comfortable for you. Yeah, so basically, okay, so we have 5 keys in the third line of this BA2 plus, and this TVM function, they calculate the if we input the sum of these numbers, number of years and interest rate and the payment amount and the present value and accumulated value, so actually it calculates the one of these quantity if the other four are given. But if the PV or accumulated value FV, future value, is not given, it is assumed 0. So in our case, that we give n, we give interest rate, and we give payment, and that we don't use accumulated value. Sorry, this is the FV in the computer. So we didn't use FV. So the computer assumed that the calculator assumed that the FV is equal to 0. So based on this information, it calculates the PV. Yeah, so this is how the TVM function in the BA2 plus works. And again, the total, this payment, the payment and the PV and the FV are all the cash inflow. So usually in time diagram, the usually payment and present value are on the other side, but here the calculator assumes that everything is on one side. So that means the payment should be negative to get a positive present value. Yeah, or to get negative present value, we have to make the payment negative. So yeah, so it's not essential. If you just type 100 as payment, then present value becomes negative 1031. Yeah, and the total cash flow is assumed to 0. So basically this is the same assumption as cash inflow and cash outflow are the same. So the TVM function in BA2 plus that works in this way. So if you use calculator, then you can solve this question quickly. And the actuarial exam is really, under the tight time constraint. So if you get used to calculator, that becomes your advantage.